Hello students, myself Kiran TR. I am here to teach you an important and exciting topic in science, magnetic effects of electric current. Let's go. Right hand thumb rule. To understand right hand thumb rule, first we must take our right hand. Our thumb will point the direction of the current, whether the current is moving from bottom to top, top to bottom, left to right, right to left. In which direction is the current moving is how we have to place our thumb. And these fingers, the other four fingers, will wrap around the conductor and it indicates the direction of magnetic field. These four fingers indicates the direction of the magnetic field and our thumb indicates the direction of current. Now let us consider there is a conductor and also assume that the current is moving from bottom to top. This is how the current is moving. So how we have to place our thumb? Like this. And these fingers which are wrapped around the conductor will show the magnetic field, which is in a clockwise direction. Now let us assume the current is moving from top to bottom. So how we have to place our thumb? This way. This is the direction of current. And the fingers wrapped around it indicates the direction of the magnetic field, which is for me anti-clockwise direction. This also indicates if you change the direction of the current, the magnetic field direction also changes. So this is right hand thumb rule. Imagine that you are holding a current carrying straight conductor in your right hand. Which hand? Right hand. Such that the thumb points towards the direction of the current. Thumb will show the direction of current. Then fingers wrapped around the conductor. The fingers which are wrapped around the conductor, these fingers will give the direction of magnetic field lines. Now we will go to magnetic field due to a current through a circular loop. Here you can see a circular loop. How is this circular loop made? A wire is taken and it is bent in the shape of a circular loop. It is connected to the positive and negative of the battery in order to give current to this entire circular loop. Here, these circles which you can see, these lines and circles which I have drawn indicates the magnetic field and the direction of the magnetic field. So these circles are nothing but magnetic fields. You can, if you observe closely, you will see these circles as they move away from the circular loop, they are becoming bigger and bigger, right? So here the circle is small. As you move away, these circles are becoming bigger and bigger circles. The same here, a smaller circles are becoming larger and larger. And you also notice that it will come to a point where if you come to the center of the circular loop, these bigger arcs of the circle will become a straight line. So there is no more a circle, but the circle has transcended to become a straight line at the center of the circular loop. These are the two things which you can observe when you pass the electric current through the circular loop about the magnetic field lines. What are they? At every point of a current carrying circular loop, the concentric circles represent the magnetic field. So these circles represent the magnetic field. Would become larger and larger. So it becomes larger and larger as we move away from the wire. So as you go away from the wire, the circles become larger and larger. By the time we reach the center of the loop, by the time you come to the center, the arcs of these big circles would appear as straight lines. So the arcs of these bigger circles would have become straight line at the center. This is the property of the magnetic field line which you observe while using a circular loop. Now, since we have understood this, we can see if the current which is passing through every point here inside the straight line will have a magnetic field which is going in a straight direction. See here, you can see that the magnetic field is going in a circular direction, right? The direction is not straight, it's taking a curve. This magnetic field line direction, it's not going straight like this, but it is taking a cut. There is a turn which is being taken, but at the center of the circular loop, you will notice that the magnetic field line is straight in direction. So in the center of the current carrying circular loop, the magnetic field has a direction that of a straight line. You can see it. Every point on the wire carrying the current would give rise to magnetic field appearing as straight lines at the center of the loop. So this magnetic field lines which is being produced by the current becomes a straight line only at the center of the circular loop. These are the three characteristic features and the properties which we can learn about the magnetic field lines in a current carrying circular loop. I have drawn a very small diagram here in order to make you understand about the next paragraph which I have written here. As you can see here, there are number of circular loop. Here it was only one circular loop, but here there are 1, 2, 3 circular loops. So we have taken 3 circular loops. When we take 3 circular loops, what happens? The current which is flowing through all the 3 loops remains the same, right? So the current is flowing through this loop, and it is also flowing through this loop, and it also flowing through this loop. The current is flowing through 3 loops. So what happens? The magnetic field is also produced in this loop, that is loop 1. Magnetic field is also produced in loop 2, and magnetic field is also produced in loop 3. Since the current throughout is flowing throughout the coil and it remains the same, but the magnetic field is produced, what happens? It gets added up. So the magnetic field F1, F2, F3 gets added up since the direction of the current remains in the same direction. When the current is moving in the same direction, the field is also moving in the same direction, and hence the field gets added up. When the field gets added up, that is, the total field in this diagram is F1 plus F2 plus F3. We have a higher magnetic field which is produced. So we can increase the magnetic field by increasing the number of circular turns. If there are circular coils having n turns, that is multiple turns, more than 1, 2, 3, 4 up to infinity, the field produced is n times larger since each circular turn has the same direction. So it is n times larger. Why? Since the current has the same direction and the field due to each turn then just adds up. Since the current has the same direction, the fields add up and lead to a larger magnetic field in a circuit of n number of coils or n number of turns. If you love to learn more and need more of these videos, click on the subscribe button and the bell icon next to it. Don't forget to like, comment, share. Love you. See you in the next video.